So thank you everybody for joining today. My name's Nathan. Love to see that, everyone's from all over the world joining today. I know Tobias he's from across the Atlantic from me in Germany. But my name's Nathan. I'm a marketing manager at Data Science Dojo, and I have Tobias Zwingman with me today. Tobias is the co-founder of Rapid AI, and like he just mentioned, he's also the author of a book fresh off the press. We will be having an ebook giveaway for this book, and there'll be 3 winners, which we'll announce at the very end. I've already released the raffle form, so just click that URL that I shared and fill it out, and you'll be entered. I'll kind of post it throughout the webinar, so just in case we have a couple late arrivals who need it, or if somebody missed it. For Q&A today, we'll do 2 rounds of Q&A, one after Tobias finishes his presentation, and then the second after we do the demo. If you're in Zoom, go ahead and post those questions in Q&A for me, because I'm gonna have a hard time moving them for you if you post them in the chat. And then if you're on one of our live streams, I've put the Zoom link out there in the chats, so you can join us on Zoom, or go ahead and ask your question in the chat, and I will actually ask it for you to Tobias. So I think that's everything I needed to say. So Tobias, if you want to go ahead and take it away and get us started, and then we'll just hit the ground running.
Thanks, Nathan. Thank you so much for the kind introduction. So yeah, hello to everyone from my side. Hello from Germany, and welcome to everyone joining in here from across the globe. Really excited to be here and sharing some things today with you around the relationship between AI and BI and how to make both work together like a dream team, and how to put all the things in practice. And I think for this introduction slide, I actually kind of skipped all of that because Nathan introduced me already with like all the most basic things, especially with my new book coming up, AI Powered Business Intelligence. In fact, a lot of those things that you will see in the webinar today, you can also read them up in the book, so you will find more in-depth information in that book on that topic, of course. And I would like to just invite you, feel free to reach out, connect with me on LinkedIn or on Twitter. Always happy to respond and connect with you. So even if you have a question, maybe after the webinar, feel free to get in touch, and let's connect there on LinkedIn or on Twitter. So what's the agenda for today? As Nathan also already said, we have 2 blocks. Basically, the first block, that will be the agenda points 1, 2, 3, and 4, will be a short presentation around common use cases for AI and BI, and how to find those use cases and how to assess feasibility for AI projects. And then in the second part, we will do a demo together. And in this demo, we will run a computer vision on PDF documents in order to extract texts and then put them into a flat table so we can analyze them in a BI system of our choice. So I'm really excited for that, and I'm happy to take questions anytime after this presentation, and we can do a quick Q&A session before we dive into the demo later. The first part, AI versus BI. I think before we really go deep into the topic, let's first discuss what is AI and what is BI actually, because honestly, if you ask 10 people about business intelligence, you get 12 different opinions. So I think for our webinar today, it's good to have a joint understanding of what BI means. And if you ask me, I really have a more or less a technical definition of BI. When I talk about BI, I'm referring to systems or software that enables business users and analysts to look at data from multiple sources within an organization. And of course, the ultimate goal behind that is to make better informed decisions. And when I talk about business intelligence, I actually really mean also the software and the tools that are used for that. For example, Power BI, Tableau, Looker, and of course, all the underlying infrastructure that is actually powering those systems. So that's what I understand with BI. And I know a lot of people have a much broader definition, but I think for today, it's good to have it focused on those tools that produce dashboards and insights and basically make data accessible to a broad audience in organizations. With that being said, what's AI? AI is similarly a very broad term, similar to business intelligence. So let's quickly dive into what AI is, at least for the working definition of our webinar today. So the term actually isn't really that new. It's been around since the 50s. And there are two general concepts that you just have to basically understand. And the first concept is the concept of general AI, which is artificial intelligence as it was originally meant to be, or it was originally meant when it was kind of invented. And that was the idea to create an AI or a system that is able to solve any given problem that the system has never seen before. And with that being said, general AI up to today is still a research case, right? It's nothing that we just that we have or that we use in production. It's still under research, and who knows when this will actually be coming true. But right now, everything we do in AI practically also, and especially in business cases, is a AI concept which we call narrow AI. And the main difference between general and narrow AI is that for narrow AI, we aim to solve a very specific problem, and we have designed a system or a algorithm or model that has been really trained and designed for this particular problem. And this is what separates narrow AI from general AI. If you take the AI which was used for a problem or designed for a problem from a narrow AI perspective and put it on a different problem, probably won't work, right? That's why it's narrow AI. It has been trained for that particular set of things. And if you go even one level deeper, then we realize that actually almost all major breakthroughs in narrow AI in the recent years has been made possible with a technology called machine learning. And because machine learning is so ubiquitous everywhere where we have narrow AI, I'm actually using those terms today interchangeably. So whenever I talk about AI and machine learning, I refer to the same things. I refer to really practical and really specific examples or specific solutions that solve specific problems. So when we talk about AI today, let's just recognize that we're talking about narrow AI and especially about solutions that are driven by machine learning. And I know probably a lot of you have already heard about what machine learning is. Just for clarity and just for this intro today, let's quickly recap what we understand with machine learning. And I think the most important thing to understand about machine learning is that we recognize machine learning essentially as a programming paradigm that is able to find patterns in data for a specific purpose, right? If you look at traditional software engineering, we have fed our computer with data and with rules, and the computer has produced outputs. And with machine learning, we turn this whole story around, right? We take data and outputs, and the machine learning algorithm will actually find patterns in the data or in these inputs that we're providing. And typically there are two phases, for example, in particular, the first phase in a machine learning process is training, and the second one is inference, also called testing or prediction. And for example, that's a very classical machine learning example from various business cases. Let's say we want to predict customer churn. So that is how many customers are going to leave the company for the next period of time. Let's say the next day, the next month, maybe even the next year for large B2B companies. Let's say we have this use case. So in this use case, we could say that we use historical data and analyze this historical data, for example, from customer transactions to calculate individual probabilities of customer churn risk. And during inference, we can then look at new customers and try to make a prediction for the next time period, if they are going to churn or not. That's a very classical ML example. So the core idea here really is to find patterns in historical data to solve a specific task. For example, putting observations into different categories, scoring probabilities, finding similarities between items, and all those things. So there's a huge variety of things that unfolds what you can do with machine learning. But just as a quick refresher here, because this is not an intro to a machine learning webinar. Okay, so now that we have talked about AI and BI and machine learning and what those concepts mean, why should we care? Why is it important? Why should we actually care about AI for BI? And it essentially comes down to this chart here on the right side, which is showing the the worldwide growth of data, especially data that is being consumed, produced, used, shared across the whole globe, across organizations, across consumers, but also in businesses. So this volume of data is growing continuously, and organizations today, they are still often able to really handle those large data volumes with modern technology, right? I mean, we have left those classic big data eras behind us where we struggled technology-wise with handling those big data masses. Like most businesses are actually not really struggling with handling those large amounts of data, right? Storage is cheap, so you can afford technology to handle this. But only some businesses are actually able to handle the growing complexity of the data with good data management. So it's one thing to store data, but it's a completely different thing to manage it well and to manage complexity. Because if we look at this data growth is not happening in nice, structured, flat tables. This growth is happening in largely unstructured data sources, text files or text documents, image documents, videos, everything that we see and consume on a daily basis, right? This contributes to this global growth. So only some of those organizations are actually able to manage that. And very few organizations are actually able to really draw insights from all those data sources because they face a huge shortage of data literate people. We have this growing data amount, but we don't have a growth of like data literate people or people who are able to analyze data or who can work with that data in the same amount. So that's a huge shortage that people or that businesses face. And that's one of the main underlying trend that is happening right now, which is fueling the demand for AI and BI. And this trend is actually fueled even by three additional factors. And the first one is that users today really demand or need quick answers from data. And it's kind of obvious, right? We are all kind of used to that. If we want some information, we go to Google or we ask Alexa and we just get this information, right? And if we are in a business setting, and oftentimes things change, right? Oftentimes it gets complicated to maybe pull even just very simple queries or get very simple questions answered. But the need is there, right? People are wanting or are demanding to get those quick insights. But at the same time, like analysts are overwhelmed with those inquiries. They can't respond to everything manually. So they have to be kind of, on top of the most important things. That means a lot of those other like not so important things just fall off the cliff and are not being recognized. The second trend that is happening is the so-called democratization of insights. What does it mean? Business users, they have been accustomed to self-service BI solutions. They have been around for quite a while. However, in today's large and complex data landscapes, it becomes more and more difficult and more complex to really pull data from all those different sources and to make sense of those data sources. So it's one thing to analyze a pivot table with maybe 10 or 12 dimensions, and a completely different story to look at something which has maybe hundreds or even thousands of different dimensions. So this is a huge challenge that is being put on the whole concept of self-service BI. And this is also fueling the need for AI and BI. And finally, the last or third trend I want to bring here is the accessibility of machine learning services. So what we see is a growing availability of low-code or no-code platforms that really make it easier than ever to give machine learning capabilities to non-data scientists and really put pressure on the BI team, because people see that those innovations and technologies are happening, so they kind of demand that also for the business. And with these three trends together, layered on top of the overall data growth, that's really fueling the demand for modern and innovative solutions in business intelligence settings. And also, I wanted to share this chart here with you. I call that BI is not going anywhere, because we often kind of forget that BI is really still a relevant topic, right? Nowadays, we tend to talk a lot about artificial intelligence, machine learning, data science, and I mean, all those things are quite like, popular. But for example, if you look at search volume in the United States over the past 5 years across like those 3 categories here, for example, you see that really business intelligence like is steadily growing. So it is a topic which is still hot in companies and which is still in demand and which still opens up problems that needs to be solved. So that's why we have to put BI really back onto the agenda and must not forget about BI when we just talk about like data science and all those fancy ML things. So it's really important to keep that up on our radar. So what are the most common AI use cases for BI? And today, I didn't want to give you just like a list of different use cases, but I wanted to provide you with a framework where you can really understand, okay, what are the impact areas for different use cases where AI can really bring value to BI and help tackle those challenges that we have just seen in the trends and the global data growth challenge. So the most common misconception really that people have is that AI is something like the next step of BI, right? They see this Gartner model here on the right side and see, okay, we have descriptive analytics and diagnostic analytics, like classical BI topics. And then we have predictive and prescriptive analytics. And maybe then after that, somewhere BI is coming into the game. But this is not true. And my goal for today is really to convince you to really embrace AI, not as a next step, but as an enabler that can improve BI systems, reportings, and dashboards really across different levels, namely across descriptive analytics, diagnostic analytics, predictive analytics, prescriptive, and even for data ingestion. So my point is that AI can really support BI across all those different stages and help to make things easier and more intuitive or more accurate. And I want to give you the first example of that, how this plays out. The first example of the application for AI and BI is what I call the application layer or the automation and ease of use impact area, because AI can really help to make the BI tool more intelligent and easier to use and more accessible for non-technical users. For example, with modern AI technology, you can comb through data in seconds and suggest insights, discover interesting correlations or unusual observations. And this is something where AI is really, really good at, right? AI isn't really good at finding explanations why something happened or providing any reasoning, but AI is really good at combing through large amounts of data and surfacing patterns. If those patterns are actually meaningful or not, that's up to us, the users who are looking, or data analysts who are looking at the data. But finding those patterns and surfacing them, that's a very good use case for AI. And this might sound really kind of like, futuristic or, anything that maybe is happening in a couple of years, but actually this is happening today. If you take modern BI tools, like for example, Power BI, you have certain visuals or certain tools that help you to identify those, what they call it, key influencers in your data, things that are triggering certain observations which you want to monitor. And these things are typically built into the BI tool. And another good example for that is, for example, the use of natural language in order to find data or to find information or insights in your data. For example, in Power BI, you have a so-called Q&A tool, which lets you enter search queries, for example, show me revenue by date or show me revenue US versus Germany last year. And then you get the corresponding charts and information shown for you. So you don't have to actually pull data from different dimensions together and do that manually. It's much more convenient to do that. And funnily, most people actually have been trained to do that like for years, because that's exactly what you do on a Google search or on a typical Google search, right? You go on Google and you search for something like, stock price for a certain company for last year, or when did the French Revolution happen? And this is something which you can do actually also in modern BI systems. And a lot of people are not aware of that. And I want to really bring that awareness to you and say, hey, there are those possibilities which you can use and which you can customize for your own use cases in order to make the whole BI experience more accessible and more user-friendly. And so you can bring more people into the whole BI system. So that's one important application area. And then there is a second application area, and that is, of course, better forecasting and predictions. This is I would say, the classic AI value area, which people think of when they think about AI. They think about predictive analytics and forecasting future events and so. And they're actually quite true about that, because AI can really help in order to make those things much better. For example, AI can help to produce better forecasts with more data and less human supervision on a macro level. That means on an aggregated level. For example, consider a very, maybe not very, but a slightly or moderate complex time series, which maybe spans across a couple of months, maybe even years. So you can use AI technology in order to analyze those time series data and then do a forecast based on just this data and then augmented by other information which you have in order to make a better prediction on that macro level. But at the same time, I'm always mentioning scale here, and this is a good example of scale at work. You can also use AI to make predictions on a micro level. So for example, let's say you want to predict the total revenue for next month, right? That would be a macro level, right? The revenue, like there's so many things in there. That would be a macro level prediction. But what you can do is you can use AI now and make predictions for every customer in your company, what their likelihood of churn is for the next month or for the next time period, and also combined with that, their revenue forecast for maybe the next couple of days, month, or even a longer time horizon. And if you have all those predictions at a micro level, you of course have more accurate overview about what is happening on a micro level as well, because you can aggregate all those micro predictions. And this is an immensely powerful tool in order to make better predictions at scale, because you're analyzing data on a micro level at scale and then aggregating that later on for the big insights. And these capabilities, I mentioned the ones before for automation and ease of use, they were built into the BI system. And the really interesting part about this part here, about the forecasting prediction things, is that those technologies are in most cases directly applied on the data layer. That means they can be applied on the data warehouse layer or data transformation layers. So they are actually quite independent from your BI system. I'm not saying it doesn't matter what kind of what BI system you use. You can always use AI, but as long as you have a infrastructure which allows you to pull those services in and to make transformation on your databases, on the data that you have, then you're always able to just show those predictions in your BI system. So that's something that's powering BI systems, no matter what BI system you're actually using. So that's why I think it's such a huge leverage for bringing AI into companies and helping people, for example, to make better predictions and better forecasts with AI technology. And lastly, the third common use case or application area that I want to highlight for you today is the so-called data ingestion layer or data ingestion area. So what does it mean? We can use AI in order to increase the overall breadth and depth of available and machine-readable data by turning unstructured data sources into structured data. For example, we can use AI to analyze text data to get sentiment scores, which are then structured and can be, reported in dashboards, for example, or to use documents or images and extract information from that, right? For example, we can count things in images. If we have footage from traffic control system, we are able to count cars on those images and translate that together with a timestamp to an aggregate of total number of cars for a certain time period. Or we can extract information from PDF forms, for example, and say we have a certain number of documents with tables or with other unstructured data in there, because we can't just directly pull it into our BI system. But thanks to AI, we can just extract them and turn them into structured data. And this is actually one of the use cases or the use case that we are doing today, where we are using PDF documents and then extracting information from that, putting that into a flat table so we can ingest that into a BI system. And once we have that, like all the other layers on top of that can of course be used, right? Because once you have data in your BI system, you can use the application layer in terms of like asking queries against your data with natural language, for example, or making predictions for the future. These are all things that layer on top of that. So it's a very powerful mechanism to unlock new data sources and then get insights and also foresights on that data. So I'm really excited for this use case today, and yeah, to showcase this use case together with you later on. So if you take all those things together, I hope you see why I see AI really as an enabler for BI across the whole analytical data lifecycle. So I think AI is not something that you can apply once your BI has reached a certain maturity and you know everything about your historic and past data, and now you just want to forecast the future. That's of course one application area. But I think what's far more important is to recognize that AI can really be an enabler across the whole data lifecycle, beginning from data ingestion to descriptive analytics and up to prescriptive analytics. And I think with that, if you have this mental framework from today, I think that will be already providing good value for you, because then you have an open eye and see, okay, what kind of use cases can I take? Can I do in order to improve my BI experience or my BI system? And in order to make this whole approach, this whole use case finding for AI use cases, not only for BI, but in general, a little bit more maybe intuitive and a little bit more structured for you, I want to give you today two frameworks which you can use. The first framework will be a use case, will be a framework to assess the value, the potential value a use case has. And the second one will be a framework to assess the feasibility of different AI use cases. And with both of them, you are able to prioritize AI use cases and build out your own roadmap in order to get your AI strategy rolling and in order to implement your AI use cases. But let's first start with the first part of that, which is finding the value in AI use cases. And one essential concept that I have really found to be really useful in my work, and I've seen good successful implementations of, is a concept called story mapping. And it might look a little bit complex at first, but it's really, really easy to do. And it's also really powerful because it can be shared also with non-technical stakeholders. And especially in this phase, it's all about non-technical stakeholders, right? In this phase, it's all about trying to explain what you're actually going to do and how that thing you're going to do is impacting the business potentially. And I'm not talking here about detailed revenue figures, but conceptually, how will things move differently, or what will be the expected change if we suddenly do something with AI versus not doing it with AI before. So the core idea here of story mapping is that we contrast the present implementation of a certain process with an AI-enabled implementation of that process. So with that, it gives you a high-level end-to-end overview of what would be different, which things you would need to change, and it helps you really to structure your thinking process. And I think this is so important, especially at the beginning, because we often tend to get carried away by technology and think, okay, hey, we could use NLP to do this, we can use AutoML to predict that, right? All those technical things come to mind initially if we are in this whole data ecosystem. But at this stage, it's really much more important to take a step back and look at the whole process end to end and see, okay, what are we actually going to do here? How are we impacting the business? And the steps we're doing here in order to facilitate that is we are having a framework saying, okay, this is the current implementation, and we're going through that step by step from left to right. And the first thing we are going to look at is the setup. And the setup describes how the process starts, and it also lists your assumptions, your resources, or your starting criteria. For example, I have filled this story map here for you for a customer churn predictor use case. And let's quickly go through that so you see just how this whole concept, the whole framework is working. So for example, in the example of a customer churn use case, we would say, hey, the setup currently, our current non-AI implementation is that salespeople get feedback from existing customers, and customer support gets feedback also from customers, right? So we have two resources, salespeople and customer support, who just collect feedback from customers, right? So that's the current status quo. Actions. That's the next step. Actions consider all tasks and action items that are executed by or on the resources which we have outlined in the setup. So for our customer churn example, that would mean that in the actions part, for example, we could say that like once salespeople and customer support have received the feedback from the customers, they are trying to figure out which kind of problems customers have and whether the problems can be fixed or not, right? Maybe that may be a pricing problem, the price might be too high, or customers need onboarding help, or anything like that, right? So they are trying to support customers in that regard. That these are their actions currently. And then the outcomes, what is the outcome of that process? And this is really the artifact, right, of the process. What is being generated or what is being modified? And in our customer churn use case, for example, the output would be that the customer support works with customers and trying to resolve like the pain points and their problems, right? And that would be very individual, right? And would be very focused on the current customer problem. And in the end, one artifact probably would be some kind of report where people say, hey, we like these were the complaints that we worked on, and these were the things which could be resolved, and these were the things which could not be resolved, for example. That would be one outcome. And finally, and that's what's all about, that's the result column, and the result column holds the impacts of the outcomes, or holds the impacts that the outcomes have on the business and or the next steps that need to be taken on the outcomes. For example, in this example here, we could say that customers will hopefully stay with the current service after the issue is resolved, right? That would be the result for the business. The customer stays because like they are happy because the customer support has worked on their problems, right? So that's the current implementation of how the company might be tackling customer churn or trying to prevent customer churn from happening. So that would be the first part of our story map. And now the whole idea is we repeat this whole similar process or whole same process for an AI-powered process. So we go through all the steps, setup, actions, outcomes, and result, and then we just go through that and contrast that with the current implementation. And how would that look like? Let's quickly go through that. So if we look at the future implementation and the setup here wouldn't include salespeople and customer support getting feedback from customers, but instead we would look at historical customer data on product usage, for example, and see if churn has happened, yes or no. So we would look at this label and this historic data. And then we would bring in sales and customer support expertise together with data analysts in order to look at this data and make sense of that. One action, the first action would be to determine key drivers for churn that can be identified from these historic data samples. And then a next action item could be to develop for example, predictive model that calculates churn for every customer, churn risk for every customer. And then another action item here would be that we have an explainable model providing insights for churn reasons, right? That could be also an action item to make actually sense of this model predictions and dive deeper into the explanations of that model. So the outcome of this process would be that each customer record would get a individual churn score or individual probability score with explainability factors attached to that. And those churn scores, for example, would be displayed in the BI and CRM system, so they are accessible for both sales and customer support. And a lot of churn projects end exactly here. I have done churn projects which do just that, right? Just show something in some BI dashboard or so, but the problem is you don't have any results so far, right? Because once we show customer churn in the dashboard, nothing happens, right? It's just there, but there's no action or no result involved. So the actual result, and that's the most important thing here to focus actually in this whole story map, is that the customer support would actually proactively reach out to customers with a high churn likelihood and also with a high value in order to help problems or help to solve problems before they actually raise a customer support ticket. So that would be the end result here, where we in this use case would hope to get a high business value because we don't see those incidents happening in the customer support, but we anticipate them upfront. And so we hope to decrease the overall customer churn rate. And by looking at this story map, there's one factor really clear, and that's why I really like this concept. It's not really a decision of either or, right? We can still go along with the current implementation. You will always need salespeople who talk to customers and customer support who gets feedback, right? But the future implementation really allows us to kind of blend the whole this whole process or old process with this enhanced churn approach to anticipate those moments where we can see or foresee that problems are going to happen, and then raise those things for those high value customers before they actually need to pick the phone and raise a support ticket. So that's why I think it's really important to look at this from a holistic perspective, and then look at this use case from end to end, because only if you have this end-to-end perspective, you're able to really assess a use case in terms of its impact and say, hey, is this use case really more impactful than another one? It's really very difficult to say in the beginning, but if you don't really have an idea about what the end goal should be or what the final consequence should be, you will never be able to make any prediction about or any estimate about the impact of a use case. So if you want to learn more about this particular thing, I have written a whole chapter on that in my book. So that's chapter 1, which goes much more into detail here, but I want to leave it like this for this presentation, so you get an overall idea of how to use story mapping in order to find out where value areas are for your AI use cases. And with that, I would like to continue over to the feasibility analysis for AI use cases. And having said that, right, I mean, we could have a whole webinar just for feasibility analysis for AI use cases. So, and I don't want to do that. I want to just give you a high level overview. How can you assess feasibility for AI use cases? What are the mental frameworks you can use? And then how can you dive deeper, and how can you actually improve your estimate for that? And the most important thing, really, if you assess feasibility for AI projects, is really to start with the data first, right? Don't think about technology first. Don't think about everything else. Start with the data first. What data do you have? And really ask essential questions such as, what data is needed for this use case? Is this data actually available? If so, what exactly do you have, right? I know we might have this data from customers' purchasing behavior, but hey, where is this data, right? Are those log files sitting somewhere? Do we have that as PDF documents? This often happens, for example, on survey data, right? I see a lot of companies who run a lot of marketing surveys across customers, but a lot of those results, especially historic data, you know, it lives somewhere in PowerPoints and PDF charts, right? That's super hard to extract. So the data is there, but it's actually not really there. So it's really important, what kind of form does the data have? Also, how do you have, do you have access to the data? How can you access it? Like I've spent in my career, like really a lot of time just waiting for data or access to data, right? Because just the company is trying to manage this overall data access policy for data scientists, for example. And also, if you have data, if you have access to it, if you can use it, are you actually allowed to do that, right? Do you have the legal authority to do that? Especially with GDPR, so data privacy regulations in Europe, but also in other parts of the world, you're just not allowed to do everything with customer data, right? You need permission for that. So it's really important to really ask those basic questions before even getting started with those AI use cases. But once you have those like basic questions answered, what you need in the next step is to have I would say, a framework to assess the overall feasibility of the AI project. And this is a structure which you can take whatever structure you like, but the important thing is you need a structure. And I have taken a structure, for example, the 4V framework. I think it's good because everyone knows that. It's really easy to explain, and you can check your data across those different categories here. Also, I don't want to go too much into detail here. You can read it up in chapter 2 of my book, but just being clear about having different categories in terms of, for example, volume, variety, velocity, veracity, and then mapping that to some kind of, scale in order to compare use cases to one another. That's really critical. Also, I wanted to give to you this chart here because we are talking a lot about data requirements and feasibility. So everything that you show in this regard, something like that is always wrong, because completely depends on the use case. But nevertheless, I found this quite useful. So because it makes a huge difference if you're trying to solve a regression problem where you probably need a couple of hundred examples to really get a first baseline model depending on the data that you have, or if you try to build a image classification model from scratch, right? That's really a completely different story. But once you have your feasibility and your impacts in place, and once you have them ready and you have your use cases analyzed, you can build your roadmap for that, right? Once you map your AI use cases according to impact and feasibility, you will identify ideally those 4 clusters here. The most important one are the champions. These are use cases which have a high impact and high feasibility. These are your first priority, and they drive your machine learning roadmap. But what is also important, and you should always mix that together with champions, these are the quick wins. They have high feasibility, but low impact. So you need to, especially at the beginning, need to get traction and show progress. So that's important to have also some quick wins in order to mix that, with champions that might be like your high level or like 1 or 2 year agenda, but quick wins can be really delivered fast, and it's important to keep up those momentums. Don't get too much distracted by research cases or cases that you need to reassess later. But there is this one note here, really do reassess later, because technology changes really fast, and what was not possible 2 years ago, or maybe even 1 year ago, is really possible today. Like I'm talking things like, for example, large language models, big advancements in neural search, for example, or computer vision technology, things which you can use as a service, just off the shelf as a service, in order to implement that in your processes, which make use cases that have had a low feasibility before suddenly very feasible, and maybe even turn them into a quick win. So it's really important to see what's going on and what developments are happening. So, and finally, that's the last chart before I wanted to go over to the demo part of this webinar, is to leave you with the what I called 5 golden rules for effective AI use case communication. And the first rule is to try to visualize everything you're going to do high level, end to end, right? Doesn't matter how you visualize it, but try to visualize it end to end, so even non-technical people can understand it. Second rule is show the complexity, show where the complexity is. The third rule is validate it always with the end user. Go to the end user and try, is that really this thing that you wanted us to solve? Define an MVP. And then the fifth rule, and really important, is, do it. Go. Just don't talk about those AI use cases. Try to implement them and try to make the first steps, and try to get the first MVP into your organization, and try to take the first steps. And with that, I would like to continue over to the demo. But before we do that, I'd like to take some questions. If there are some questions from the audience, then I would like to take them from you.
Yeah, and I think we only have, right now, we only have one question. More may come in. But Tobias, my suggestion is let's answer that one question and then move right into the demo, because I think we're a little behind schedule.
Yeah, I think so also. Okay. There's one question, which is, what use cases do you have for AI with X data and O data? I don't really understand this question, actually, honestly.
I'm not sure either. So Shane, if you can give us a little more context, like, is there a certain industry that you're looking for a use case for?
Yeah, maybe we can take this question again for the end of this presentation, and
sure.
Yeah, otherwise I'll head over to the demo. Just quickly opening up my tab here.
Yeah, and while Tobias is opening that up, I did share the link for the demo. So if anybody needs me to share that again, please let me know. But just let me know.
Okay, hopefully you should see the screen with the Google Colab notebook opened up. So again, because I think like technically we have like 10 minutes left or so for this session, right? If this is correct. Like everything in this Colab is really kind of documented, so you can actually also run that by yourself. I just want to like go through that with you. So what we want to do here is, we want to pass documents with AI, and the problem statement we're looking at is, to summarize that really quickly, let's say we are, for example, a consulting company and we have like salespeople traveling all around the country. And what we want to figure out is like, where are they traveling? What are the most like typical routes? What costs are they, like what costs are happening? And above all, like when are those costs happening? So how can we map that to an actual date? So we are interested in booking dates for train rides, for trip origins, trip destinations, and ticket prices. So it's actually a hands-on use case, which is also using real-world data, because we are looking at train tickets from high-speed trains, intercity high-speed trains in Germany, and we are going to analyze those documents, which are like automatically generated every time you purchase a ticket and then sent to the company, so they can analyze those documents at scale with an AI service. So we are going to look at that. And the solution overview, so how are we going to tackle this? Going to pull up this chart here. We are essentially looking at 3 layers, so the data layer, the analysis layer, and the user layer. In our use case lab today, we are focusing especially on the data layer because this is where most complexity currently is. We are taking PDF documents, in this case not from Azure Blob Storage, but we just download them from a URL. We load the file. We call an AI service for each file, for each PDF document, which is this ticket receipt. We call the Azure Cognitive Service Computer Vision AI service, which lets us analyze those documents. And then we transform those AI results, filter those results, get the information we want, and extract that into a flat table, which you can then use to feed that into Power BI, essentially. Before we can actually do something or get started with it, we just to make some preparations here. And the first thing is, like, of course, we need an AI service, right, for that. And the AI service we are using in this example is Azure Cognitive Services for text analytics. But you could actually use, for document analytics. You could actually use any AI service for that. For those of you who have an Azure account, I'm just quickly showing you how to set that up, how to set this up. If you don't have an Azure account, you can sign up for that for free. Just visit azure.com, get a free trial account, and then you should see a similar page like this here as a dashboard. And then you just type for cognitive services. And after that, you see the computer vision service here, over here. You can just hit create and then create this resource, which will bring you to this computer vision service. And if you do that, you will see a list, because I already did that here. You will see a deployed computer vision AI service. There's nothing that you have to do, right? It's just deployed for you, so you can just query that, and it will provide you a key and an endpoint for that AI service. And I'm just copying the endpoint from this AI service over here and filling this in to this notebook. Also copying the key right now. Also, this is all happening on the free tier of Azure, so there are no costs involved. We can just execute this one and run it. Nothing happening right now, just definition of our variables. And we'll import some packages, some pandas, numpy, datetime for working with the time data, and then the SDK for Azure for calling this AI service. And then finally, let's get some data here, and just download those files. And this cell here is basically just limiting all files to this one simple observation, because I don't want to run everything now in this demo and set everything to the AI service. This would take too much time. But what we now have is, like, we have now a folder here with different PDF documents, so just to give you to take a look how this is actually playing out. So this is one PDF document, and how this is looking at. And what we're doing now is sending those documents to the AI service in order to analyze that and get the information that we want. let's call or define the function for this AI service, which is just the function for calling this remote service. It's actually taken from the documentation of it, so nothing you really have to worry about. It's only just for sending the file to the AI service. And we will facilitate this API call, just sending one item or one example to this service. I'm just having a sleep timer here because for the free tier, you're not allowed to do more than 20 calls per minute for this, for this service. And let's inspect the response. So this is how the AI looks at our service. It basically just extracts text information from the PDF and it provides so-called bounding boxes, right? So this is how the document comes back from the AI service. And as we can see, like most complexity will be to get the information we want from this batch of documents or from this batch of information here. Because to recap, if we look at this PDF document here, I highlighted in red those items that we actually want to extract from this PDF document. Right? We want to get this dollar amount or euro amount here. We want to get the date, and we want to get the it's called the halt, so from like the origin and the destination of this stop. And what we have to understand is that in this service, each text item or each text block is indicated by a bounding box. And this bounding box has those coordinates here. And those coordinates are really, really handy in order to extract information from the document because they allow us to get data from this document based on the relative position of this data on the document. And once we know that certain items are always on the same areas or same areas across different, after different keywords, for example, it's very powerful to extract those information. So let's see how that turns out and how those transformations are happening. First of all, we are trying to extract the dates by keyword. What I've done here is I have written a small function which is called get text by keyword, and it's actually not doing much but just looking for a certain keyword that we define and trying to get all items that have a subsequent hit after that keyword from our target response object. So if we, for example, call this now here and say we are looking for the keyword, in this case datum, that's what I searched for in the result object, we exactly get one hit, and this is this one here. Of course, it's a little bit pre-processed as we took the original the original string and then turned that into this datetime format here, but that's just pre-processing in Python. Okay, so now we have the date from this document. Let's try to extract the train stops. That's a little bit more difficult, but not too difficult either. Instead of using pure keyword search, we are now using we're now locating the image or locating the information by looking between different keywords, because this section that we need is always between this headline here and this headline which comes after that. So if we define a function like this, which doesn't only look for one keyword but two keywords, we can extract all information which is between those two keywords. And this is this text block which we see right here, right? So we see all those text information in this between those like keywords that we defined. The only thing we need is actually this one here, Hamburg and Leipzig, as the train stops. So how do we get that? And it's very easy actually, because we can just blend or just get this information by applying a bounding box filter to that. Because we can say, hey, we have all this data here from this whole collection, and now we just need one item here, this left part actually. And this left part, we can identify that by the bounding boxes. So there's a filter here for the bounding boxes, and those bounding boxes can now be called using this function here. Looks complicated, but in the end, it's really just applying the steps that I try to explain now pretty quickly, and trying to set the filter accordingly, which exactly leads to the two observations being being returned here in that regard. So take a look at that here. The code is really, I think, commented well, so you can see what's happening and going on. Also, this example is also in the book, so you can also read upon that in the book. And the last item that we just need for our use case now is finally the price. and the ticket price, we can actually really get that easily using a keyword search. And we see if we look for this keyword Betrag, we see the output will be 92 euro, and our final data set, for example, in this case is like the date here, the start and the destination, the price, and the reference to the original document. And now this is really easy to wrap that up into a flat table. And if we had not only looked at one observations, but at 100 or 1,000 observations, we would of course have 1,000 different rows. And with this structured data, it's very easy to come up with a, for example, dashboard in Power BI or Tableau or whatever BI tool we want. And I think this is really a easy way to pull that in a BI tool, for example, and do a analysis such as, for example, saying, hey, what were my cost breakdown per year? Like what were my spend per month? Maybe I even know that from credit card billings, but what I don't know is like, what were my top destinations and what were my top routes that my salespeople had, and maybe which routes were the most expensive ones. So these are all insights which I can now derive from this data without actually doing any manual effort on extracting information from those PDF documents. And yeah, I think there was a bit a quick walkthrough through that document, but with regards to the overall time, I think we have to keep it quick here. And I would like really to take some questions for this lab, because I see there are some raising hands and also some questions in the chat, and I would like to take them right now. Nathan, what do you think? Do we still have time for them?
Yeah, let's do some Q&A, especially because I need to put everyone through the random number generator to to pick 3 winners.
Okay.
But so to in regards to the hand raised, I think Jeremy is the person with the hand raised. Sorry, Jeremy, I can't give anyone microphone rights because my colleague Fatima has done a really good job with marketing these events, and sometimes we get trolls. We found it best not to give anybody microphone rights, and if you could just use the Q&A tab, we'd appreciate it. And so Tobias, why don't you go through? I think there's some context for Shane's question.
Yeah, exactly.
But go through the Q&As. I do have one question from YouTube that I'll ask you once you've gone through these ones, and then we will announce the winners and sign off.
Yeah, perfect. Sounds good. So I would start with the last question for Mariam. She asked, does the book contain this example or similar ones? And then, yes, it does exactly contain this example. So that's why I also kind of like speeded through this whole thing a little bit, because you can read it all up. That's a whole chapter in the book where I really explain step by step how to build this use case. So if you're interested in that, check out chapter, I think it's 9 in the book for turning unstructured data into structured data. So that's all there for you to read up. And then I would like to come back to the question from Shane. And Shane asked or said, your presentation kind of touched it already. For context, I was thinking of debt collection industry. Typically, persons spend a lot of time looking at their operational data, but there's sometimes not enough effort when it comes to looking at experience data that comes from customer feedback. I was hoping to get an example of better using AI to help with analyzing feedback from CSAT forms, social media responses, keywords, etc. Yeah, this is actually exactly what I tried to demonstrate here. I took the example of using PDF documents, but of course, this kind of experience data is oftentimes unstructured data. For example, in my book, I have another chapter or another example where I take customer reviews from booking sites, for example, where we take those customer reviews and then try to turn that into structured data. And in this context, structured data was a sentiment score where we can say, hey, which feedback was positive or negative, and then on the next level, if it was negative, what were the actual terms that triggered this negativity in this comment? So we were able to analyze which things like Wi-Fi or bedrooms, this was a hotel example, what were the things that actually triggered those bad experience for customers? So I think this is really, this really comes down to that. Yeah, we can use AI to turn this unstructured data into structured data. There's another question. Why do we need to use Power BI when we can go from Colab to GCP to Google Data Studio? Can we not do what you did in Azure instead on Google Cloud? Yeah, of course. I'm really trying to be like technology agnostic here. So I'm just using Azure Cognitive Services as an example, but you can use Cloud Vision from Google, or you can Amazon Recognition from AWS. They all have those services, and the same actually applies to BI tools like the dashboard which I've built here. You can also build that in Data Studio or Tableau or anything else. The point I wanted to make is that you can use AI at this ETL or data ingestion layer to turn unstructured data into those like flat tables. And once you have those flat tables, any BI system can just ingest them, right? The only difference where like the BI tool makes really a difference is when you want to automate or make the user experience in the BI system easier. For example, if you want to ask questions of your data with natural language, that's not possible in every BI system, right? It's possible in Power BI. I don't know if it's possible in Google Data Studio. I'm not sure, honestly. But if it's not possible there, you can't just add this functionality on top of that, right? So that's why I use Power BI in this example. But otherwise, of course, all those tools are interchangeably, right? And that's why I wanted to give you those high-level frameworks in order to find out, hey, what are the impact areas, and do I have a tech stack which is actually leveraging or using those capabilities, or do I have more potential there? Yeah, good question. I think this was everything I have in the Q&A tab. Nathan, I think you had one more.
Perfect. I have two questions. The first is, and both of these are from LinkedIn. And I guess there was something mentioned about 4V. I honestly wasn't able to pay much attention to the presentation because I was all over the place. But is the 4V publicly available? And again, I'm not sure what that is in reference to.
The 4V framework, probably, yeah, that's probably available. So you can just Google for the 4V framework. Otherwise, I'm also happy to share the slides. Like if anyone wants to have the slides, I can also share them. Just contact me on LinkedIn or Twitter. I'm happy to share the slides with you. So no problem.
Yeah, and Tobias, if you want to share them with us as well, we can actually add them as a reference material in the
of course,
in the descriptions and stuff.
And
then the next question is, what if my company system doesn't support AI, but I need quick wins for buy-in?
So what you can always do is draw those AI use cases on a conceptual layer, right? The thing that I laid out over here. This one, right? Actually, a lot of AI use cases live or die on that level, because if you're not able to really convince stakeholders, management stakeholders from your use case on that level, I think you don't even need to have the technical fundament in order to do anything. Because if you you need to be able to tell that story and say, hey, what triggers or what level, what do I want to change actually? What's the point that I'm going to make here, right? I'm not advocating for using AI for the sake of using AI, but trying to put that into some context. But obviously, if you don't have any tech stack right in front of you, my personal organization hack would be to just download Power BI to your computer. It's free of charge. You can just use it locally, Power BI desktop, and it has a lot of AI features built in, and you can also run Python and R code within Power BI. So you have it kind of under the hood and under the radar. So that would be maybe a good trick for that.
Okay, and then let's do one final question. And sorry, I know there are a couple more questions out there. Let's do one final one because we're already about 10 minutes over time. And I also want to be able to announce the winners because I have them chosen. So final question, where do you think visualization is going as a technology tool?
Sorry, can you please repeat that? Which one?
Where do you think visualization is going as a technology tool?
Yeah, I think visualization will become more and more important actually. Visualization is coming from that, hey, let's draw a pie chart, right, in order to visualize some data. But meanwhile, people are really recognizing that or acknowledging that as an interaction interface for data. And I think it will become more and more like that, right, where you are able to not only tell a story, tell a data story with visualization, but also use visualizations in order to provide an interface in order to interact with data more more intuitively. So I think there will be great things to come for the whole visualization tech stack in data science industry. So I'm pretty sure about that.
Okay, perfect. So with that, let's wrap up here. So I do have 3 ebook winners. Hopefully you're still online here with us. If not, I will email each of you. If you are announced as a winner, I'll confirm it with you via email, and then also I'm going to be sharing your information with Tobias, who is going to share it with his publisher, I think, and then his publisher will reach out to you about how to claim your ebook. Um, and again, I will mention this in an email to you as the winner. So congratulations. And again, I think Tobias and I mentioned at the start about butchering people's names and never being able to get it right the first time. So I apologize in advance. But our first winner is Halal. I think it's Jen. So congratulations, you won our first ebook, and I will send you an email with what I just mentioned here. Our next winner is Terry Liu, who, if this is the Terry I'm thinking of, this person is also an alumni or an alumnus of our, I think, our boot camp. So congratulations, Terry. And then our third and final winner is Paulo Tavares. Congratulations, Paulo. So to Halal, Terry, and Paulo, look out for an email from me. It'll just be, confirming that you are in fact winners, and I will be sharing your information with Tobias, and Tobias and his publisher will be reaching out to you. Next week, or not next week, actually tomorrow, July 13th, we have another webinar. This is at 10 a.m. Pacific, so an hour and a half before this one started. So a little earlier than we normally host these webinars, but we're going to be detecting silent failures in ML models, and this is going to be, and I'll get their name correct tomorrow, but again, I'm going to butcher our presenter's name, Wojtek Kuberski, the co-founder of NannyML. And by the end of this webinar, we're going to be able to detect drop-in performance of ML models without using ground truth data, monitor machine learning models, and understand how to detect data drift to resolve the issues we find. So join us tomorrow for that. You can find that on our website, which is online.datasciencedojo.com. And again, Tobias, thank you so much. We'll have your recording up and running here probably around Thursday. And we'll have the link to the demo. Also, I believe we'll get the link to the slides as well on there as reference points. So Tobias, thank you so much. And to our winners, congratulations, and everyone else who joined today. Happy to have you, and I hope we see you tomorrow.